Hello everyone. This video is on the Knewton Alta assignment for section 6.3 called Logarithmic Functions. Alright, so in this video I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But all the objectives are the same, the structure is the same. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. Alright, so your assignment page, right, you should have your title, the mastery bar, right, telling you how far along you've gotten, your objectives. This one's pretty big. Looks like there are 6 objectives. Okay. And it looks like they're broken up into sections, so you're doing these 2 first and then completing these 4. Then under the current objective, there should be a question related to that objective. And then at the bottom of every question, you'll see a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. That's for instructors only. But you will have a more instruction button. If you're ever struggling with a topic, try clicking on this. It'll take you to a page with some reading or some videos to study. And then you can work on problems related to that instruction and get through the assignment that way. Alright. So the first objective here I'm looking at is convert from exponential to logarithmic form. Alright. So I have to talk about logarithms here. Alright, so when they say an expression is in exponential form, means it looks like this. You know, we have a say a base b to an exponent, I'll say p for power, so b to the p power equals, you know, some number, so I'll just use like n for number. Again, the parts of this, right? You have a base, you have a power on that base or an exponent on that base, and then equals, you know, just some real number over here. And you may recall when we were dealing with exponential functions in sections 6.1 and 6.2, we wanted this base to be positive. Alright, so we're still going to do the same thing here. Have it so that the base we're working with is a positive number, right? So again, if you saw back in section 6.1, some bad stuff can happen, some unusual things can happen, things we don't like when the base is not positive. So if the base is positive, you know, you take any positive number and raise it to any power, any real number exponent, the resulting number, this n over here, is going to be a positive real number. But it's got to be positive. Because you can't take a positive number to any power and get some negative number. That will never happen. Because if you recall from, again, exponential functions have a range that's all positive numbers, right? Everything above 0. Alright, so this is called, you know, exponential form. And this statement that b to the p power equals n can be written in an equivalent way. Alright, so this is equivalent to saying the following. That's why I got the double arrow here. And we can take this statement in exponential form and rewrite it in what's called logarithmic form. Logarithmic form. Now, one note I'm going to make is that logarithms logarithm is just a fancy word for exponent, but just written in a different way. Logarithms are exponents, and exponents are logarithms. So if I take my exponential statement here, the exponent, p, the exponent, is going to be this thing called a logarithm. So we have, changing from one form to the other, we have the exponent p equals the logarithm, which is represented by the letters log for logarithm, and then the logarithm has a base on it, just like any exponent does, but the base is written as a subscript. And the base on the logarithm is just the base on this power, p, over back here in exponential form. So if exponent p, the power p, has a base of b in exponential form, then p will be equal to the log base b, and they write a little b down here, in logarithmic form. And then it's a function, right? So just like any other function, you're going to have a logarithm of, logarithm base b of, and then you probably guessed it, the number that goes inside the parentheses here is just this positive real number n over here. And these two statements mean the exact same thing, just in different forms. All right, but they mean the exact same thing. So once again, over here, this little b under the word log, that's the base of the logarithm, and again, it's got to be a positive number. And over here, right, where the p equals, this was the exponent on that base in exponential form. Exponent on the base b in exponential form. But now it gets its own side in this logarithmic form. And then this input, this is called a logarithmic function, right? It's like f of x, g of x, so it's log of something, log of n. The input of the log is some it's got to be a positive real number. Can't be 0, can't be negative. What goes inside a logarithm like this input, this is also referred to as the argument of the logarithm, the input of the logarithm, has to be a positive real number. Okay, can't be 0, can't be negative. So they have the same stuff in it. They both have this b, p, and n. They're just in different places and look different, but they mean the same thing. Now, an example of this before I get into the actual question, with some numbers you probably know already. So here's a statement in exponential form. Say 3 to the second power, 3 squared equals 9. Right? You have a base, an exponent on that base equals some positive number, and again the base is positive as well. So this has the exact same meaning. Right? You can go back and forth between these as saying the following, saying that take the exponent, give the exponent its own side, 2 equals. So the exponent on this base of 3, the exponent gets its own side, and like I wrote earlier, Exponents are logarithms. Logarithms are exponents. So that exponent equals the logarithm. So equals log, logarithm. The base on the logarithm, right, the subscript, is the base on the exponent. So base 3 of 9. Right, the number that 3 squared was equal to. And same thing over here. If you see this, you see log base 3 of 9, or the logarithm of 9, base 3, I've heard both said. That's equal to 2 because the base of 3 to the power of 2 gives me the number inside the logarithm. Right? 3 to the second power equals 9. Right? They mean the same thing. Here's another example. So say I asked you for, what's the log base 2 of 16? Or the logarithm of 16 base 2. So again, what this is equal to is an exponent. Logarithms are exponents. It's an exponent that the base 2 needs to be raised to get 16, and that would be 4. Right? 2 to the 4th power is 16. And again, these are equivalent statements. This is in logarithmic form. This means the same exact thing as 2 to the 4th power equals 16. All right. And I could do this all day long. All right. Make up all sorts of examples, but there's just a couple there. I'm hoping it makes sense a little bit. All right. And we'll see plenty of it throughout this video and the rest of Chapter 6 stuff. All right, so now, the question we're given is, convert from exponential to logarithmic form. We have this 4 to the a power equals 12, right? This is in exponential form. Positive base to some power equals a positive number. Like I've been saying, these statements in exponential form can be written as an equivalent statement in this logarithmic form. Remember, I like to do this, give the exponent its own side. Pick an exponent. Well, there's only one exponent here, a, and say a equals a logarithm. Right? Exponents are logarithms. Logarithms are exponents. I'll say that a bunch. Now the base on that logarithm is just whatever the base on that exponent was back here in exponential form, and that would be base 4. And then the argument or the input of the log function is the positive number here, 12, right? 4 to the 8th power is 12. And they mean the same thing, just look different. And then if we look over here, the only one, now they have, the sides switched, but that's this one right here. A equals the log base 4 of 12. Or the log base 4 of 12 equals a, right? If you just switch the sides. No, it's the same equation. Right, then after you submit an answer, it'll tell you if you got it right or wrong, and then give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something was right or wrong, and hopefully you can learn from your mistakes for future questions. Alright, next. Alright, so sticking with the same objective, convert from exponential to logarithmic form. Here we're given a statement. So I'm going back to my paper, I'll write this out. So I've got it right here. Right, here's exponential form, the equivalent logarithmic form. You should be able to go back and forth between these very easily. And we're told, hey, here's a statement. That's true, right? 10 to the second power is 100. And we're saying change this to the equivalent logarithmic statement. Well, there's only one exponent over here that I can really focus on. So 2 is a logarithm. And the base on that logarithm is going to be the base on the 2 from the exponential form. That was base 10. So I read a little 10 here. And then, the input of the logarithm, right, in parentheses. So the log of what is that positive number on the other side, the 100. Right? So the log of 100, base 10, is 2, meaning that 10 to the second power is 100. Right? They mean the same thing. Now, one thing I do want to point out here that's also new, very often, log base 10, because you work with decimal numbers quite often. Almost every number we ever see is a decimal number, base 10. Log base 10 is very often just written as log, just log. So that means if there's no base, if there's no little number underneath the log, it's base 10. You're going to be assuming that. And this is called the common logarithm. Because, we work, it's very common that we work with numbers that are in base 10, are in decimal form. So, base 10 is sometimes referred to as the common base. So this log base 10 is often referred to as the common logarithm. And then one other thing I'm going to point out, just because it might come up, I'm sure it will. If you ever have log with a base of e, remember that number e is about 2.718 something. If you ever see a logarithm with a base of e, and that's usually not written that way for some reason. Right? And because e actually comes up quite a bit in studies of natural phenomenon. In fact, e is sometimes referred to as the natural base, and a log base e, a logarithm base e, is often referred to as the natural logarithm. Is log base e. Well, instead of writing log base e like this, you're going to see, and this is on calculator buttons and stuff too, just ln. Logarithm natural, if you want to think about that. I know it's like Logarithmic natural or something like that. My French is terrible, but you're going to see ln when they really mean logarithm base e. And if you just see log with no base, that means you're in base 10. Please know this. So instead of writing log base 10 of 100 like this, you're going to see log of 100. Right, and they're the same thing. So back on the assignment, right, that's this one here, log of 100. See how there's no base on it? It's assumed to be base 10. Pardon me. Okay, wonderful. All right. Now we're going the other way around. And again, it should be very simple to go back and forth if you know the forms. Right? So convert from logarithmic to exponential form. All right, so I'll do the same thing where I'll write this out, and we'll change it to its equivalent exponential form. So again, I got them here, the general form. So this time we're given the log form. The log base 2 of 6 equals a. Or if you like having the log on the right side, right, this is the same exact thing as a equals the log base 2 of 6. And when you're changing it to exponential form, remember the little number under the log is the base. So that's base 2. The number the logarithm is equal to is the exponent. Right? Logarithms are equal to exponents. Logarithms are exponents. Exponents are logarithms. So 2 to the a power equals, and then the input, the number inside the logarithm, equals 6. And that's what they want. Take this logarithmic statement, write the equivalent exponential statement. They mean the exact same thing, just look different. And that's this first option here, 2 to the a power equals 6. Great. Alright, so here's another one, logarithmic to exponential. So again, this time we're given the log base 9 of x equals 5. Now, you don't have to switch the sides, but remember the little base on the log is the base over here, and then the number the log is equal to is the exponent. Logs are exponents. So 9 to the 5th power equals the argument. And you might see some books where they write this out. They do a little loop. Like 9 raised to the 5th power equals the argument. 9 raised to the 5th equals, and that's a quick way to think about how to change from logarithmic form to exponential form over here. So x equals 9 to the 5th power, and that would be the solution of this equation. You solve for x, get x alone, and we're going to see that a lot later too when we're solving logarithmic equations. Very often we'll have to transform to exponential form to get the variable by itself, like in this example here. So x equals 9 to the 5th, 9 to the 5th equals x. That's this last option. Okay. So here's another one. Again, these should be pretty quick after a while. But we're given the log form first, right? The log, the base is z, and you're going to assume that z is positive, right? Positive bases. And the number inside the logarithm also must be positive, which is 4, equals 6. All right, and I'll do that little write-up, that little loop again. Remember, take the number that's the base of the log, this little number under the log. You raise it to that number on the other side, the exponent. And that will be equal to the argument, equal to this input. So z to the 6th power equals 4 is the equivalent exponential statement. So that's the second option here. Great. Alright, this one now, see, sometimes the 10 will be there, sometimes it won't. Just remember, if it's just log without a base, it's base 10. So this would be 10 to the 7th power equals x. So this second option here, very, like I said, very quick after you've written out a few and gotten some practice in. And then we're going back the other way, 10 to the 4th power equals 10,000. So that means, the exponent 4 is equal to the log base 10 of 10,000, or the log of 10,000, which is that there. Again, it should be quick, in my opinion. All right, and then one more of those. So 8 to the a power equals 20. Right? So remember, the exponent a equals the logarithm. A equals the logarithm of 20 base 8. Log base 8 of 20 equals a. And that's this last option here. Great. So again, I'm hoping that after seeing me write a few of those examples, it helps. Like, you should, though, be able to transform back and forth, translate back and forth between exponential and logarithmic forms pretty quickly. Alright, so now we're going into that other section of 4 objectives. Okay, so here's evaluate logarithms with positive integer solutions. So what's the value what's this equal to? Right? Notice there are no variables here. Now LOG, those are not variables. Please don't think that. L, O, and G make the word logarithm. This is a function. This is not a variable. Right? So if there are no other letters besides L, O, and G, you have a number. So the log base 3 of 81 is a number. All right, let's evaluate it. So the log, base 3 of 81 equals something. Now remember what it equals. It equals a power. This is equal to, an exponent that you would raise the base 3 to get 81. Exponent you raise 3 to yielding 81. Right, so 3 to the what power equals 81. That's basically what this is. If I called this question mark and then change to exponential form, that's what it would look like. Right? Well, I'm hoping you know some of your powers, right? 3 to the 4th power, 3 times 3 times 3 times 3, that's 81. So the log base 3 of 81 is equal to 4. And this is what they want, right? What's the value of that logarithm? And again, you go back and just change to exponential form and see if it makes sense. Is 3 to the 4th power equal to 81? Absolutely. So these are indeed equivalent, and the log base 3 of 81 is 4. So you're going to have to know some powers here. Okay. Here's one with negative integer solutions, right? So same thing, right? They give you a logarithm with no variables, and just say, what's the value of this logarithm? What's it equal to? So same deal. Got the log. We're given the log base 2 of 1/32. What is this equal to? And remember, the equivalent exponential form would be 2 to what power? 2 to the question mark power equals 1/32. Now I'm hoping that you remember your negative powers. If you know the positive powers, you know the negative powers. Remember, negative powers are just the reciprocals of the positive powers. Alright, you may remember that 2 to the 5th power is 32. So 2 to the negative 5, right, 2 to the negative 5 power is 1/32. 1 over 2 to the 5, right, the reciprocal of 2 to the positive 5. So the answer here is negative 5, right? The log base 2 of 1/32 is negative 5, and this is what they're asking for, right? The value of that logarithm, the power you would need to raise 2 to in order to get 1/32, 2 to the negative 5th. So negative 5. Okay. I've mentioned common logarithms. Remember, this is log base 10. Log base 10. So this is really no different than the previous problems. They say what's the log of 100? Just remember that when there's no base under the LOG, it's base 10. So again, if I say this equals I don't know, think about what this looks like in exponential form. This would be 10 to some power equals 100. And what is that power? Well, that'd be the second power, right? 10 squared is 100. Right? 10 to the second power is 100. So the log of 100, the log base 10 of 100, the common log of 100 is 2, since 10 to the second is 100. So the value is 2. Okay. Alright, so here again, log base 4 of 1/64th. And this will be probably the last one I write out until we get to the new objective, but the log base 4 of 1/64th. Remember, I'm hoping you remember that negative powers are the reciprocals of positive powers. You might recall that 4 to the third power is 64, so 4 to the negative third power would be 1/64th, right? So the answer is -3. Right, 4 to the negative third power is 1/64th. So this logarithm base 4 of 1/64th is -3. And then now this is an easy one. Log base 6 of 6. 6 to what power would be 6? Well, that'd be 6 to the first power, 6 to the 1. The log base 6 of 6 is 1. Alright, since 6 to the 1 is 6. I'm not going to write that out. Alright, and then I already mentioned the natural logs. Remember, natural logarithm means log base e, right? That e number, the 2.7 something. So you see here, find the natural log, the log base e of 2.1, and round to the nearest tenth. If necessary, include a leading 0 with any decimals less than 1. Okay. So this one you just have to use a calculator for. Now a lot of calculators have a ln button. So you just punch in 2.1, then hit the ln button, or you type in this as it is if it's like a graphing calculator. I'm just going to go straight to the free online calculator, that Desmos site, and I'll just do the calculation off to the side here. ln of 2.1. That's natural log base e of 2.1. And 0.7, right? 7.4, but they asked us to round to the nearest tenth, right? Just one decimal place. So 0.7, and that's it. That's all they want. 0.7. Okay. Yeah. So all these, I think all these natural log, because base e is not a nice number. E is not like 2 or 10 or 4. It's not a whole number, not an integer. So for most of these, you're probably just going to have to go to the calculator. Yeah, so natural log of a half. Log base e of a half. So e to this power, is going to be a half. So negative 0.69, and they said round to the nearest tenth, so negative 0.7. Negatives, and they said put in leading zeros, right? So negative 0.7. Great. Yeah, so I think for the natural logs, you're just going to have to go to some calculator of some sort. All right, now here, this is when you can use a calculator. I mean, nothing wrong with going here and punching it in. Now remember it's log, and when there's no base, it's assumed to be base 10, and then 1 over 10,000, and you're seeing -4, right? Because remember, 10 to the 4th power is 10,000. So 10 to the negative 4th power would be 1 over 10,000. But I'm going to stop using the calculator. We don't need a calculator for this. It's a nice integer. But 10 to the negative 4 would be 1/10,000th. All right, and then again, the log base 5 of 125 equals, just again think, what power, what exponent would I need to raise 5 to get 125? Well, that would be the third power. 5 to the 3 is 125, so that logarithm is equal to 3. All right, the log base 6 of 216. 6 to what power is 216? That would be the third power again, right? 6 to the third power is 216. So that logarithm is equal to 3. Okay. Yeah, after you get the hang of a few, these should be pretty simple. The log base 5 of, now be careful, right? This is a fraction less than 1, 1/25. Now remember, 5 to the second power is 25. So 5 to the negative second power would be 1/25, right? So the answer here is -2. 5 to the -2 would be 1/25. That logarithm is equal to -2. Here, what's the log base 6 of 1/36? Same thing. 6 to the second power is 36. So 6 to the -2 would be 1/36, right? The reciprocal. So the answer is -2 again here. 6 to the, that logarithm is equal to -2. Okay, yeah, so it looks like, we start flying through these once you get the hang of them. All right, now here, see when they say round to the nearest hundredth, round to the nearest tenth, you're going to be using a calculator. Because, remember, this is log, this is base 10. There's no base here, it's base 10. So like 10 to what power would be 0.9? Like, I don't know. 10 to the 0 is 1, 10 to the first is 10, 10 to the -1 is 1/10. Like, I can't tell you off the top of my head what power I need to raise 10 to get 0.9. So that's why we're just going to go to a calculator here. Right. So remember, this is log though. This is base 10, log of 0.9. Oops. Now notice when I keep 0 in there, it says undefined, right? Remember the number inside the logarithm has to be positive. I mentioned that a lot earlier. So the log of 0.9 is this, 10 to this power. This crazy power would be 0.9. And that's -0.05, right? If I round to the nearest hundredth. Before 5, they bump that up to 5. -0.05. -0.05. Okay. Wonderful. All right, then one more here. Now this one I don't need a calculator for. You could still use one. Nothing wrong with that, but I mean, this is again log base 10, right? A common logarithm. And it's just, the log of 100,000. So remember what that's going to be equal to. That's going to be equal to the power I need to raise 10 to get 100,000. And that, that's got 5 zeros. That's 10 to the 5th. The answer is 5. All right, this logarithm is equal to 5. All right, so that objective's done. I just got one more with the natural logarithm, so I'm just going to be using calculators again, because they're going to ask me to round to the nearest tenth and all that. So remember, this is log base e, ln, this ln, natural log, log base e. E to what power is 3.5? I don't know. I know e to the first is e. E to the second is e squared. I don't even know what those numbers are exactly. I know that e is about 2.7. Alright, so I definitely need a calculator for this to help me out. Round to the nearest tenth. Alright, so back here, and make sure you're doing ln, right? Natural log that they asked for, the log base e. So e to this power, 1.25276, right? E to this power would be 3.5. And to the nearest tenth, that'd be about 1.3. Right, if I go to the nearest tenth, 1.3. And then I should have just one more of those. Natural logarithms, log base e, the ln. And again, it's something I couldn't tell you without a calculator. What's the natural log of 80? E to what power would be 80, right? I'm going to guess, it's about 3 point something, maybe 4, but again, I don't know. I don't know off the top of my head, so I need a calculator here. So again, use a graphing calculator, whatever calculator you have that has ln attached to it. But again, this Desmos site is free. Just natural log of 80. a little more than 4, right? 4.4, right? We were asked to round to the nearest tenth. So e to the 4.4 power would be about 80. And great. And that should be it for this preview version. I hope you understand, like I said at the top of the video, that the questions I saw here may not be the same questions that you see when you work on the assignment yourself. But, you know, all the objectives the same, all the structure is the same. And you just got to remember, you know, what logarithms mean. Right? A logarithm is equal to an exponent. It's the exponent I need to raise the base to get the number inside. And also, you know, you should be able to transfer back and forth between exponential form and logarithmic form. And I'm hoping that watching me go through these examples here helps you in some way, you know, when you work on the assignment on your own. And thank you very much for watching.